Hello students, now let us try to understand the concept of ionization enthalpy and electron affinity in terms of the thermodynamics. Okay, so in terms of thermodynamics student, ionization energy and electron gain enthalpy, okay, or electron affinity are defined at absolute zero or defined at absolute zero. Absolute zero means that is you are not going to calculate the change in ionization enthalpy or electron affinity. You will be able to get this one as a absolute value. Now next one is at any other temperature, heat capacity for the reactants and products have to be taken in account at any other temperature and heat capacities. Okay, for the reactants and the product you have to take you have to be taken into account, but ionization energy and electron affinity are defined at absolute zero. Okay, now let us see student enthalpy for the reaction. For ionization enthalpy, that is we have to from the gaseous isolated gaseous atom we are putting the we are getting the isolated gaseous cation plus electron. This is the concept of the ionization enthalpy, okay, expression. And for the electron affinity, m gas is there plus electron is getting added. It is m negative for the electron gain at a temperature T. Okay, at particular temperature T is how we can give the equation delta RH naught is equal to RH naught T equal to delta RH naught 0 plus integration of delta R CP dt. The value of Cp for the E species in the above reaction is 5 by 2 R. Cv is equal to 3 by 2 R. Okay, and delta R Cp naught is equal to T is equal to plus 5 by 2 R for ionization enthalpy, and delta R Cp naught T is equal to minus 5 by 2 R for electron gain enthalpy. So ionization enthalpy and electron gain enthalpy, what we have to use the sign here is plus 5 by 2 R, and here is the in the electron gain enthalpy minus 5 by 2 R. Now let us see, therefore delta RH naught ionization enthalpy, delta E naught ionization enthalpy plus 5 by 2 RT, delta RH electron gain enthalpy equal to A electron affinity minus 5 by 2 RT. The same way how we are going the second point, if Cp of the reactants and products are temperature dependent, if the Cp of the reactant and product are say temperature dependent, how can you calculate delta H2 minus delta H1 integration of T1 T2, okay, lower limit T1 upper limit T2 delta R Cp dt, and similarly delta E2 minus E1, that is integration of T1 T2 delta R Cv dt. So this is how we are going to get the ionization enthalpy and electron affinity. Okay, so ionization enthalpy and electron affinity are defined at absolute zero. At any other temperature, heat capacity for the reactants and products have to be taken in account. That already I mentioned how the ionization enthalpy electron is getting removed. For electron gain enthalpy, electron is getting added. So this is the expression for the enthalpy, and that also we have to I have explained Cv 3 by 2 R and Cp, that is 5 by 2 R. So these things has to be taken in the consideration. Thank you so much for watching, friends.